Algebra 1, Section 3.5, proportions and similar figures. Quick definition of similar figures would be, in layman's terms, they would be same shape, different size. One of them's bigger than the other, but they're the exact same shape. Proportionally, they are. They are proportional to each other. There is a symbol that goes along with similar. This actually pairs very nicely with a lesson that we'll have in geometry as well, and it's this symbol that you see right here, that little tilde there. That means is similar to. So they are saying triangle ABC is similar to triangle DEF. Okay? Now they want you then to find X. And there's two things that are true about similar figures. Maybe you already know them. One of them is that all of their angles are the exact same measure. All the angles are congruent. Congruent is a geometry word for equal measure. And that's true whether we're looking at triangles as you are now, or whether we're looking at an octagon. And if it's something like an octagon, they would have to be congruent angles in the right order, right? So angle A, and I don't want to get into that too much, but basically this angle and this angle are congruent, and then you go one to the right, and those two angles need to be congruent, and then the next, and then the next. It can't just be mix and match for them to be similar. The second thing is that their sides are proportional, and that's what we're going to build upon here, is because I can find X if I would compare 9 and 6 in a fraction and set it equal to X over 8. Now listen, I know that you can get a correct answer by doing this a few different ways, but I want to train you correctly here. If you go 9 over 6, you're doing it the correct way, and then you want to go X over 8. To say that differently, your fraction should be comparing corresponding sides. Your fraction should compare corresponding sides. Don't go X over 9 equals 8 over 6. Yes, that delivers the right answer, but you're not learning it correctly. You're not learning similarity correctly if you do it that way. Compare this side to this side. Now, if you did it the other way around, if you did 6 over 9 is equal to 8 over X, no problem, okay? Because you're still comparing this side to this side, and then this side to this side, one triangle to the second triangle. And you know what happens in either one of these models? As soon as you cross multiply, you're going to have 6x equals 8 times 9, which is 72. Either one of these first steps brings us to this step after you cross multiply. And then divide by 6, and you'll find out that x is 12. Okay, the missing side there is 12. Next, triangle DEF has these vertices that you can see there. They're ordered pairs. It is dilated by a scale factor of 3, and the origin is at the center of the dilation. Again, this is a really nice pairing with something that we'll do in your geometry curriculum once we get to that. And basically what you have here, and I'm going to show you some notation, is if you have D, which is -2, 2, it maps to something that we'll call D prime, little apostrophe kind of thing. They call that prime. And all you're going to do, if it's a scale factor 3, is multiply both numbers by 3. So this would be -6, 6. E being 2, 1 would map to an E prime that is multiplying by 3, 6, 3. And F being -2, -1 maps to F prime, which is -6, -3. Okay? And you don't need to show this work. I'm just showing you what I'm doing there. You just multiplied every number by the scale factor, and you have it. Now they're going to have a graph for you just to make this look real nice. And there it is. This is the original triangle. And basically, each one of the vertices, they should be using prime there. This should be D prime, E prime, F prime. It's a little bit more geometry notation than algebra, but I might as well just teach it to you now. And don't think that it's like 3 times as big. Look, if we calculated the area of these, the bigger one would be more than 3 times as big. Think about how many of these little triangles that you could fit inside here. I could fit another one right here, another one right here, and there'd be a whole bunch of space left over. So there's a different something to that as far as area. But basically, each of the vertices has expanded away from the origin by a factor of 3. Something I show geometry classes is that there's a ray that passes from the origin through D and D prime. A different ray that passes through the origin through E and E prime, and the same thing with F and F prime, because they're just expanding away from the origin. Okay, moving on. A flagpole casts a shadow of 102 feet. A 6-foot tall man casts a shadow of 17 feet. How tall is the flagpole? So here's a situation. We have a flagpole with a shadow of 102 feet. A 6-foot tall, and I'm not drawing this too much to scale, but let me get a little bit closer. A 6-foot tall man casts a shadow of 17 feet. Now, would you agree that these are similar figures? You should. Hopefully the man is standing straight up and down, perpendicular with the ground. Hopefully they planted the flagpole to be just the same. And if this man is 6 feet tall and we want to know the height of the flagpole, we can set up a proportion because these are really similar figures. Similar right triangles is what they are, right? Now, why are they similar? They're similar because we would know that these angles would be congruent and that these two angles would be congruent, right? And that's a characteristic then of similar figures, right? In particular, similar triangles. Again, something we'll touch on in geometry. So it's not because of the sides, it's actually because of the angles, and then we can solve for the missing side, which is the flagpole. X over 6 is equal to 102 over 17. Again, you could do 6 over x is equal to 17 over 102. But please don't just compare one to the other, right? Don't compare on the same triangle. So cross multiplying real quick, I'm going to use my calculator. And that's 612. Sorry if I had a little hiccup there. One of the custodians just walked in my room and I got a little flustered, I guess. And then dividing by 17, turns out the flagpole is 36 feet. There we go. One more. The scale of a map is 1 inch to 10 miles. The map distance from Vacaria to Gifford is 2.25 inches. Approximately how far is the actual distance? Now, most of you are going to be able to look at that and go, okay, you take 2.25 and you multiply it by 10. And that's correct. But I want you to see this. This is actually, I was going to write it for you, but they actually have it here for you already. This is actually a rate, 1 inch to 10 miles. And then when we have 2.25 inches and we're trying to find the number of miles, this is a cross multiply problem, okay? So if 1 goes with 10, 2.25 goes with what? I don't know. And you'd cross multiply and you'd get 1 times x, which is x. And here's why you're multiplying. Here's your logical reason why you would multiply 10 by 2.25. And that, of course, is going to be 22.5. And notice that that's this, so it's in miles. All right, thanks for watching.